All right, so now I need to show you about the circle. So in order to do some of the other special angles, what we're going to be doing is we're going to be taking a look at the unit circle. I guess this is part 3, the unit circle. And so first I have to give you the definition of a unit circle. A unit circle, or the unit circle if you want, is a circle with a center at 0, 0 and a radius of 1. So the reason why it's called the unit circle is because a unit is essentially the number 1. So 1 is called a unit, okay? So the radius is 1. That means that the equation is x squared plus y squared is equal to 1 squared. And if we take a look at the unit circle and I draw the unit circle, it has a center at 0, 0. And if I labeled all the points around the edges here, because my radius is 1, this point right here would be at 1, 0. This point right here would be at 0, 1. This one would be at negative 1, 0, and this would be at 0, negative 1. So this is what the unit circle looks like. We use the unit circle and our angles in standard position to calculate values for angles like 0 degrees, 90 degrees, 180 degrees, 360 degrees, negative 720 degrees, and so on. These are sometimes called quadrantal angles. But we don't really need to worry about that. They are the angles that end up on the axis. So the x-axis and the y-axis, right? They are on both of the axes. So what we have to do is we have to combine this idea of the unit circle with what we had as well with our trig ratios. So if you remember, and I'm just going to draw the unit circle one more time because I'm going to lose it on my diagram here. I'm going to combine really crappy unit circle. I combine a unit circle with our angles and standard position circle. So our unit circle right here, 1, 0, 0, 1, negative 1, 0, and 0, negative 1 sitting in here. This angle right here, this spot right here, is where 0 degrees ends, or 360 degrees ends, or negative 720 degrees, and so on. This angle up top here is for 90 degrees, and negative 270 degrees, and 450 degrees, and so on. This spot over here is for 180 degrees. Remember, they're always measured from OA, which is over here, or negative 180 degrees, or 540 degrees, and so on. And this angle down here at the bottom, this is where 270 degrees ends, or negative 90 degrees, and so on. So they're all very, very specific spots. How we try to figure out the ratios is like this. Remember that when we were dealing with angles in standard position, that's O, that's A, and somewhere on here there's this point P, x, y. In a unit circle, the only difference between this and what we have been doing is that the radius is equal to 1, which means that this is going to be 1. This is still my x value, this is still my y value, but my radius is 1 because we're dealing with the equation x squared plus y squared is equal to 1. So let's watch to what my ratio is going to look like. So for the unit circle, and again, this is what we are using for the unit circle, sine of theta, there's my theta sitting in here, is opposite over hypotenuse, which is y. Cosine theta is adjacent over hypotenuse, which is x. X over 1 is x. Tangent theta is opposite over adjacent. Think about this though. This y value that I'm talking about right here is the same y value that you'd find in a point. So therefore the sine value is the y value of our point in the unit circle. This x value that we've got right here is the same as that x value right there. Therefore, cosine theta is the x value of our point. It is alphabetical, not perfectly. In the alphabet, x comes before y, and cosine, c, comes before sine, which is s, not directly before. For this one, you kind of just have to remember that it's y over x. Notice also that it is your sine value divided by your cosine value because this is y and this is x. If you are going to then go for cosecant, cosecant is the reciprocal of sine, so instead of y over 1, it would be 1 over the y coordinate. Secant theta is the reciprocal of cosine, so instead of x over 1, it would be 1 over the x coordinate. And of course, cotangent theta is the reciprocal of tangent, so instead of y over x, it would become x over y. Now, how does that work? Look at our unit circle. At 90 degrees, the point that we're looking at is at 0, 1. The 0 is my x value. The 1 is my y value. So that means that sine of 90 degrees, look over here, sine of 90 degrees is my y value. Sine of 90 degrees is 1 because it's my y coordinate. Cosine of 90 degrees is 0 because it's my x coordinate. Cosine theta is x. If I wanted to find tangent of 90 degrees, I'd have to go my y coordinate divided by my x coordinate. And remember, 1 over 0 does not exist. We can't divide by 0. If you think about it from before, it was an asymptote line. We're not graphing tangents just yet, so don't worry about that. But this does not exist. So you can put no solution or you can put does not exist for this one, okay? If I was trying to find cosecant of 90 degrees, it would be 1 over my y value, which is going to be 1. If I was trying to find secant of 90 degrees, it would be 1 over my x value, which does not exist. I'm going to abbreviate it, DNE. If I was going to try to find cotangent of 90 degrees, it would be the x coordinate, which is 0, divided by the y coordinate, which is 1, and 0 can be divided by 1. 0 divided by 1 is going to be 0. So what we want to be able to do is maybe find something like this. Find the value for, let's try a couple of these. Let's try one. Sine of, let's see, negative 450 degrees. So again, the first thing that you want to do is you want to draw it. We're going to start from here. We're going to go in the negative direction, 90, 180, 270, 360, 450. We're down here. We're on an axis, and as soon as we are on an axis, we are therefore going to be using the unit circle. Okay, so here's our unit circle sitting right in here. Our unit circle is going to be, and we're at the bottom, remember all the points. This is 1, 0, this is 0, 1, this is negative 1, 0, this is 0, negative 1. So when we are taking a look at this and we want to be able to figure out what our value for it is, really decide that you're using the unit circle for this thing, and then what we can do is we can figure out our ratio using those x's and y's. So let's figure out which ratio it is that we want to be able to use. We want sine of negative 450. In the unit circle, sine theta is equal to my y value. So let's take a look at our point and let's take a look at our y value. So sine of negative 450 is going to be negative 1. Trying another one. Let's do secant of, I don't know, sounds good, 180 degrees. So again, secant of 180 degrees, let's draw it first. 180 degrees, 90, 180, lies on an axis. Therefore, it's the unit circle. Secant theta goes with cosine. Cosine is our x coordinate, so secant is going to be 1 over x. Well, let's take a look at, I'm just going to use my unit circle up here. Let's take a look at 180 degrees, which is right there. If I want to take a look at 180 degrees right there, I'm looking for 1 over my x value, which is going to be negative 1. Finally, let's do, I don't know, tangent of 270 degrees. So if I count 90, 180, 270, there I am again down here. That point is going to be at 0, -1. That's my unit circle right there on the axis. Tangent theta on the unit circle is equal to my y value divided by my x value. So it is my y value, which is -1, divided by my x value, which is 0, and that value does not exist. So what you need to be able to do is you now need to be able to memorize the 2 triangles and 1 circle and practice day, let's count it, 1, let's see, 2, 3, 4, probably day 5. Day 5 in your homework. And what's going to happen tomorrow on day 6 is that you are going to be dealing with equations with these things. So please make sure that you do practice your day 5 homework and you're comfortable with your 2 triangles and your 1 circle.